Hello children, now let us see the graphs of a quadratic expression in different conditions. Suppose y is equal to ax square plus bx plus c, where a, b, c are real and a is not equal to 0. Then the graph between x and y is a parabola. In figure 1, 2 and 3, a is greater than 0 and the parabola is called concave upwards. Its mouth is open upwards. In figure 4, 5 and 6, a is less than 0 and the parabola is called concave downwards. Its mouth is open downwards. Alpha and beta are two roots of the quadratic equation ax square plus bx plus c is equal to 0. Point P is called apex of the parabola. It is given by the coordinates minus b by 2a, comma, minus d by 4a, where d is discriminant. In figure 1 and 4, d is greater than 0. That means roots are real and distinct. Above the x-axis, y is positive and y is equal to ax square plus bx plus c. That represents this curve. In figure 1, curve is positive when x lies between minus infinity to alpha and beta to plus infinity. And curve is negative when x lies between alpha to beta. In figure 4, curve is positive when x lies between alpha to beta and curve is negative when x lies between minus infinity to alpha and beta to plus infinity. In figure 2 and 5, d is equal to 0. That means roots are real and coincident. In figure 2, ax square plus bx plus c is greater than 0 for all x except when x is equal to alpha or x is equal to beta. And ax square plus bx plus c is equal to 0 when x is equal to alpha or x is equal to beta. In figure 5, ax square plus bx plus c is less than 0 for all x except when x is equal to alpha or x is equal to beta. And ax square plus bx plus c is equal to 0 when x is equal to alpha or x is equal to beta. In figure 3 and 6, d is less than 0. Curve neither touches nor crosses the x-axis. So roots are imaginary or complex conjugate. In figure 3, ax square plus bx plus c is greater than 0 for all x. And in figure 6, ax square plus bx plus c is less than 0 for all x. Maximum and minimum values of a quadratic expression. Suppose y is equal to ax square plus bx plus c. When a is greater than 0, this curve represents y is equal to ax square plus bx plus c. Y minimum will occur at the vertex and y minimum will be equal to minus d by 4a. When a is less than 0, this curve will represent y is equal to ax square plus bx plus c. Y max will occur at vertex and its value is minus d by 4a. So y max is equal to minus d by 4a. Let us solve 4 questions based on what we have learned so far. First question, find the minimum value of the expression 2x square plus x minus 1. There are two methods to solve this question. First method is related to quadratic expressions and second method is related to maxima and minima. First method, the given expression is in the form ax square plus bx plus c. So comparing, we get a is equal to 2, b is equal to 1 and c is equal to minus 1. Discriminant d is equal to b square minus 4ac. So d comes out to be equal to 9. A is greater than 0 and b is greater than 0. So graph of 2x square plus x minus 1 will be something like this. Y minimum will occur at point P, which is apex of the parabola. Its value is given by minus d by 4a. So y minimum is equal to minus d by 4a, which comes out to be equal to minus 9 by 8. Second method, suppose a is equal to the given expression 2x square plus x minus 1. Condition for minima is dA upon dx is equal to 0 and d square a upon dx square is greater than 0. So dA by dx comes out to be equal to 4x plus 1. We will equate this to 0. So x is equal to minus 1 by 4. Next, we will confirm that at x is equal to minus 1 by 4, minimum occurs. And that can be confirmed from here, d square a upon dx square. So d square a upon dx square is equal to 4. 4 is greater than 0. That means at x is equal to minus 1 by 4, minimum will occur. Put x is equal to minus 1 by 4 here. So a minimum is equal to minus 9 by 8. Second question, if y is equal to x square minus 2x minus 3, then find the range of y when x is real, when x lies between 0 and 3, and when x lies between minus 2 and 0. We can solve this question easily by drawing the graph. First, compare the given expression with ax square plus bx plus c. So a is equal to 1, b is equal to minus 2, and c is equal to minus 3. Discriminant d is equal to b square minus 4ac, and that is equal to 16. Here a is greater than 0 and d is also greater than 0. So graph of the given expression will be something like this. Apex of the parabola will be at minus b by 2a comma minus d by 4a. Minus b by 2a is equal to 1 and minus d by 4a is equal to minus 4. So the apex will be at 1 comma minus 4. This is shown by point P. First part, when x is real. When x is real, it can take any value on the number line. So we need to consider all the points on this parabola to get y minimum and y maximum. Quite clearly, y minimum is minus 4 and y maximum will occur at infinity. So y minimum is minus 4 and y max is plus infinity in this case. So range of y is between minus 4 and infinity. Second part, when x lies between 0 and 3. When x lies between 0 and 3, we need to consider this part of the curve between c and b. So y minimum will again be minus 4 and y maximum will occur at point B and its maximum value is 0. So y minimum is minus 4 and y max is 0 in this case. So range of y is minus 4 comma 0. Third part, when x lies between minus 2 and 0. When x lies between minus 2 and 0, we need to consider this part of the curve between E and C. Quite clearly, y minimum will occur at C when x is 0 and y max will occur at E when x is equal to minus 2. So put x is equal to 0 here to get y minimum. So y minimum is equal to minus 3 and put x is equal to minus 2 here to get y max. So y max is equal to 5. So range of y in this case will be minus 3 comma 5. Third question, if a, b, c are real, then in y is equal to ax square plus bx plus c, comment on the sign of a, d, alpha plus beta and alpha beta. Here alpha and beta are roots of the given quadratic equation. By just observing the given graph, we can say that a is less than 0 and d is greater than 0. So part 1 is a is less than 0 and part 2 is d is greater than 0. Third part, sign of alpha plus beta. Here both the roots alpha and beta are negative, so their addition will be negative. That means alpha plus beta is less than 0. Sign of alpha beta. Since both the roots are negative, so their product will be positive. So we can say that alpha beta is greater than 0. Last question, find the range of the expression 4 into 2x minus 1 upon x plus 1 whole square minus 2, where x is real. To solve such questions, suppose y is equal to the given expression. So y is equal to 8x minus 4 upon x square plus 2x minus 1. Cross multiply to get a quadratic equation in x, and that is yx square plus 2y minus 8 into x plus 4 minus y is equal to 0. Given that x is real, so discriminant d is greater than or equal to 0. Compare this equation with ax square plus bx plus c is equal to 0. So a is equal to y, b is equal to 2y minus 8 and c is equal to 4 minus y. So discriminant d is equal to b square minus 4ac, and that is 2y minus 8 whole square minus 4y into 4 minus y. Since d is greater than or equal to 0, so the inequality is 2y minus 8 whole square minus 4y into 4 minus y is greater than or equal to 0. After simplification, this inequality is 8 into y minus 2 into y minus 4 is greater than or equal to 0. Critical points will be at y is equal to 2 and at y is equal to 4. Now draw a number line, mark points 2 and 4. Draw a wavy curve starting from top right and passing through 4 and 2. Inequality is greater than or equal to 0. So we need to consider the zone which is above the number line. So y lies between minus infinity to 2 and 4 to plus infinity. And that is the range of the given expression. In next video, we will see location of roots. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.